so we're all on the same page when we talk about deep retrofits, and some people say deep energy, but it's really about more than that. It's really about emissions. We're talking about buildings that are getting ready to fit under Canada's 2050 net zero aspirations, basically more than aspirations, necessity. So net zero ready, emissions neutral, 2050 ready. And why? So emissions reductions, obviously, lower total costs of ownership, reduced energy costs, maintenance and renewal that can get done along the way, enhanced durability, and there are subsidies and incentives for some of this work. And the value proposition includes often enhanced appearance and higher resale value, way better comfort, healthier indoor air quality, and peace of mind. And just to kind of put the emergency in perspective, buildings are responsible for about 40% of total GHGs. And if we 70 to 80% of the buildings that will be using in 2050 are already built. So we've got to fix them. So this is a graph that was generated by the staff at the City of Edmonton in the climate unit that shows just how fast we have to bring GHGs down. And it's important to realize, and it was prepared in 2018, and we're not where we need to be at the rate we're emitting in Edmonton, and this graph looks the same pretty much across the planet. If you look at the UN climate change folks, we're going to blow through the GHG allowance for a 1.5 degree fair share for Edmontonians sometime in the next 6 or 7 years. So, and it's really not, like, in some ways it's unhelpful to think about the emissions per year. What really matters is the total emissions. Like we're emitting at the rate that like the emissions from materials and all that kind of stuff is up there on day one from new buildings, and bringing us closer to overflowing that tub. So there are lots of different kinds of retrofits and lots of different solution sets. And I'm going to give you some examples of each of these just to sort of illustrate that, and by way of showing how we need a roadmap, a set of tools to guide us to the best, most cost-effective solution set for any given building. So you can do it all at once, which is always cheaper. It's way more money up front, but it's cheaper in the long run. Or you can do carefully planned stages where you try to leave the bill, and in some cases you'll do the envelope only. In other cases, envelope and mechanical, probably most common. And there are a few cases where mechanical only will do it, particularly in Manitoba, where you've got really clean energy. And I'll have examples of all of those. And then there are multiple ways of doing the envelope as well, and we'll look at a few different examples. We have 8 million single-family houses in Canada and about 14 million dwellings in total. So we actually need to do about 600,000 a year. So and they're complex projects. So we'll go through these examples fairly quickly so we can talk more about, how do we create a set of tools for dealing with this. So this is a retrofit that was done about 6 years ago to a 1947 house here in Edmonton. It had good bones, was in a neighborhood that was undergoing renewal and needed all kinds of work. And so they my colleague Stuart Fix from Renew Engineering gutted it completely because the inside needed work as well. Replaced the windows with Duxton triple glazed Louis Argon windows, and we built a whole new wall, site built, like a stick construction, wall panels to get it up into sort of net zero territory. We added at the end of the day, we had our 40 walls, our 60 roof, and 0.7 air changes an hour. So essentially the same kind of specs that we would want to see in a net zero building. At the other end of the scale, this is my house where I'm talking to you from now. It's an R2000 house that I built. It's a duplex that I built in 1999. And so it's got, the finishes are new. It doesn't make any sense to do anything to them. So my road to net zero for this building involves putting in a geothermal system, which I'm very fortunate to have room for, and upgrading the glass. I can get much better glass today, and a couple of my sealed units are starting to fail, and adding a little bit of insulation in the attic. And so, you know, those are the opposite ends of the scale. And then this is a project that we're heavily engaged in right now. We're on building number 10 of 15, using an energy sprung panelized approach with some assistance from Enercan. It's essentially an R&D project. We've, you know, by going from building to building, it's given us the opportunity to refine what we're doing and learn a ton from the process. So if you know, for anyone who's not familiar with it, the Dutch energy sprung system is an approach that they've developed to deal with their hundreds of thousands, I think millions actually, of post-war townhouses. These buildings were built, they're in with almost no insulation right after the Second World War, and they have developed a system where they can transform these things in a matter of about 6 weeks, like a townhouse building. And it starts with a digital capture where they scan the building with LiDAR scans, take that back to the office, and use that to design wall and roof panels that are made in a factory, and come out basically wrapping that building in a nice warm sweater. And in fact, they go further. The roof panels have solar racking on them, and the contractors are guaranteeing zero on the meter. So if your housing association is guaranteed that the meter will read zero, that these will be completely net zero. They've done about 5,000 units. They've got about 10,000 more in the works, and their pilot project was 110,000. Yeah, so we're trying this out on the Sundance Housing Co-op. We started with the digital scan. It was 55 scans in total that are sort of smooshed together into one giant point cloud that the surveyor clips out the individual buildings for us and sends us those point clouds, and we extract the building geometry using a program called Undet that works inside of SketchUp and Revit and I think a few other programs as well. And once we have the geometry, which is not level, square, or plumb, just like the buildings aren't. We've judiciously fudged them to be level, square, and plumb. And then we slide window and door components around to, you know, a few millimeters here and there to try to get the best fit on this somewhat fuzzy point cloud. And it's a nerve-wracking process because you know, the first thing about panelization is you're committing to getting these things to fit. If you've got a crew of 6 people and a crane, and you've got windows that are properly installed and all taped and made airtight, and they don't fit, you've really lost most of the advantages of like, you're stopped in your tracks. So from the extracted geometry, we are designing, we design and dimension and detail panels that that will be made in a basically, it's a big workshop. It'd be a bit much to call it a factory. They have a 20-foot framing table. These are very simple 2x4 panels, but they come out right ready for us to install with the windows on them. And while they're being built, we're getting the rest of the building ready. So to insulate the foundations, we're using a hydrovac truck to suck a narrow slot. I think this is something that was pioneered south of you in Minnesota, where they actually poured foam in, but we're using a graphite infused low carbon, relatively low carbon EPS that we just drop into the slot after inspecting for cracks and that sort of thing. And then we've got a panel support box that's PWF and designed to carry the loads of the panels, the porches that we're replacing, and porch roofs and additional overhangs and all of that kind of stuff. We're also electrifying the site so that we can completely ditch the gas lines, and we're running parts of the new electrical service in the panel support box, saving us a whole bunch of hydrovac trenching, which I'll talk about in a sec. And so while we then get the building ready by loosening the existing windows so that on panel raising day we can move quickly. And we're also adding egress windows to every unit. There's a kind of a while you're at it thing that goes on with these deep retrofits that tends to push the cost up a little bit, and that is, you know, you sure don't want to do this afterwards. You don't want to be adding new windows through two walls and trying to tie air barriers in a weatherproof, airtight, you know, hydrothermically sound way. So any changes you want to make them now. And there are a zillion little details to consider as you're doing it. We need to prepare for the new HRVs and heat pumps, and deal with the existing hose bibs and electrical service connections and all of that kind of stuff, which we do entirely in our panel support box. So as I mentioned, they're very simple 2x4 standoff panel with cellulose insulation that's injected on site. They're triple glazed, low E argon Duxton windows, actually from your neck of the woods, that essentially make that wall ready for a net zero thing. And then the big day for us is the day we fly the panels. It's pretty exciting and nerve-wracking. As I mentioned, if those things don't fit, we've got major problems. But I'm happy to say that so far, every panel has fit, and it's a little less tense as we go through this. And the co-op, we're in kind of a tight box too, because a parallel project that was done in Ottawa for Ottawa community housing, they shrunk the windows an inch in each direction. These windows were not as big as they should have been to start with, probably. So we're shrinking them by about 15 millimeters in width and nothing in the height. And so we've got a high bar, but it's working. We have an adjustment in the panels themselves, so we can slide them back and forth to get the best fit on the windows, and that seems to be working so far. So for the roofs, we're basically doing the sort of Harold Orr chainsaw retrofit. We're sawing off the existing overhang, wrapping it in poly, leaving the shingles on, and tying that into our exterior air barrier on the panels for a complete airtight seal, and getting pretty good results. And then we add another R50. They started off with R28, and so we're keeping that vapor barrier warm enough not to worry about condensation on it. We started off installing the siding on the panels, but we found that we were spending so much time trying to knit them together that we started to omit it. When we add the cost of knitting the siding over the panel joints and over our cellulose fill holes, and add that to the cost of the installation in the workshop, it's more than if we just hired a subcontractor to come in after we've got the air barrier done. So that's what we're doing now, and it also frees up our crew to move on to the next building a little sooner. So ultimately, we've got the very similar recipe to what we would design, how we would design these buildings to be net zero, except for the basement floor, which people have been living in the co-op for a few original members there, and they're full of stuff, the basements, and we would have had to adjust the stairs, and it would have been far more disruptive for the owners. So we let that part go. It was on a cost per kilowatt hour per year saved basis. It really was at the very high end of the scale and unaffordable. And because we're tightening them, we're having to add HRVs, which we're figuring out how to install fairly sort of laparoscopically with minimal disruption to the homeowners and minimal drywall repair. And we're also replacing the existing furnaces, ditching the gas lines, and installing air source heat pump heating and hot water systems, which required us to upgrade the electrical service. The utility considered the 60 amp service system that was serving the existing units to be close to the end of its life, and so there was no willingness to upgrade that. We essentially took over the servicing of the site and installed a new service that we distributed using directional drilling and some remote sheds with step-down transformers to apply, to get the service up to about 120 amps. And then the icing on the cake is a solar system that's it's a 350 kilowatt system in total. Because the buildings are mostly facing east and west, we're not going to be able to get enough economically anyway, enough solar on the roof to get 100% of their total annual energy needs, but they've contracted to buy renewable energy from Southern Alberta wind and solar for the balance. So that's pretty much as close as we can get to net zero, and I think a reasonable response. So the overall, and we're struggling to meet this budget with COVID and the current inflation, but we're somewhere around $130,000 a unit, so it's expensive, but it's really much less expensive than trying to do this in stages. We're you know, it will be there for a long time, but we're in and out fairly quickly on the individual units, and the idea of doing this one in stages would be pretty unthinkable, I think, and impractical. So we're trying out, you know, the lessons that we've learned on the Sundance project on 3 single-family houses that from the 50s and 60s. There are 8 million single-family houses, and the GHG, the cumulative GHG impact from these is far bigger than it is from multifamily, and it's critical that we learn and develop a somewhat affordable way of doing this, or we're never going to meet our GHG needs. And you know, I looked at that occasionally when I'm doing this work. I think, man, this is so hard. This is impossible. What if we just ignored the GHGs from buildings and did everything else? You know, upgrade our grid, transportation, all that kind of stuff. Well, you know, the sad thing is that we're guaranteed 3 or worse degrees if we do that. So we're trying to make this work on single family houses, and it's working not too badly. It's also expensive. The panel system is working. So we're in the middle of doing these 3 houses. The first one we started, this one is just being sided right now. The other 2 of the others are have their foundations, and one's foundations and the mechanical system and the roof have been done, and we're just waiting for our panels. And on the third one, we've done the foundation and the mechanical system, and are moving toward doing the rest of it. We hope to have these close to done early in the new year. But just to, you know, in a microcosm, we've got three houses here, and 3 different roof systems. So on the first one, because we had a very little room in the existing structure for insulation, we're doing a built-up roof over. We also couldn't we couldn't guarantee that we could add the extra weight, so we developed a sort of a truss system to install a whole new roof over. And the owners wanted, this is in an historic neighborhood, and the owners wanted to make this 1950s house look like it had been built in the 20s. So we're adding a quite historically sort of faithful porch to the whole thing as well. So, you know, some of the cost is going into some of those kinds of things. And the 1960s house, and there's another kind of lesson here. It turned out the most economical approach was to suck the existing insulation out of the attic, and they had, being early adopters, they had already put solar panels on the roof and had about R50. And when you combine the original shavings with the cellulose, so we made the difficult decision to suck all that out and discard, you know, landfill it basically. spray the attic with spray foam, which and then we're putting our 50 cellulose back on top of that to give us somewhere around our 65. So just, you know, I'll come back to this in a minute when talking about piecemeal partial upgrades that are being done for the most part with our government subsidy money. So on the third one, we're doing a scissor truss over. They had some asbestos in the vermiculite insulation in the attic, and we decided just to leave that be and cut off the overhang and wrap over the top like we're doing at the Sundance project. So in many cases, people can't do it all at once. This is a deep retrofit that I'm helping with in Kingston, Ontario. These folks they bought a house that had a simple shape, lowish, needed outside work, and was pretty much original, so that they weren't paying for other people's kind of unplanned upgrades, and then asked us to develop a plan for them to get it to net zero. So what we started with an energy model and a kind of an assessment of the building and what it needed, and then developed a 3-stage plan to do that. So they had some water issues in the basement and no weeping tile. So that was a perfect opportunity to add the outside insulation just for the cost of the insulation. And at the time, you know, when that's being done, this is going to be done fairly shortly here. The basement windows will get done, air sealing the outside of the foundation, and it'll be left in a way that makes it easy to tie the wall air barrier into that when that's being done. And they'll also fix the grading issues. And in stage 2, which will probably get done, you know, at the same time as the foundation, actually. But so they've got asbestos in their attic. They've got about R20 in total, if that, with a combination of sort of scattered fiberglass bats and the original vermiculite. So they'll do the same thing. They'll get that asbestos abated, do spray foam to air seal it, and then add cellulose on top to give them the right amount of insulation for the sort of optimum amount for their climate zone. And at that point, they can think about electrifying their heating and hot water and adding an HRV, but that could also still wait until they do the walls. That'll depend a little bit on the cost. And so the third stage would be to replace the windows with high performance windows, add insulation with a continuous air barrier sealed to the windows and foundation, and the attic air sealing that was done with a spray foam, and then replace the furnace hot water tank, ditch the gas line, and switch to air source heat pumps, and add solars. So many ways to do this, but what we can't do is keep on doing these piecemeal upgrades, the kind that are that our Greener Homes grants are providing incentives for, because the unintended consequences and the wasted money are just unaffordable. when you consider that we've got to get every house to net zero by 2050. This is an example from the Sundance project. Siding was getting pretty rough. They decided they needed to do something about that. The windows had already been replaced with low argon or with double glazed windows, like 15 or so years previously. The siding contractor wouldn't put on any more insulation than about half an inch, because it would have meant having to deal with the windows. And so there was no attention to air sealing, how this would tie to the foundation or the attic. We've basically since covered that up. So that money is completely wasted. And this happens, in all three of the SSIRIA projects, where two of them had solar, one of them we had to take it off and put it back. They had all upgraded their attic insulation without paying any attention to air tightness. One of them had put in triple glazed windows with no relatively low performance and sliders, like 8 years ago. So really, you need a comprehensive plan to avoid this kind of waste, and the sooner we can encourage the government of Canada to move in that direction and to require a kind of a net zero roadmap. You don't have to do everything at once, but you need a plan to net zero, and you shouldn't get a penny if what you're doing is not part of that plan and it's going to leave that building ready for the next steps. So we think the retrofit roadmap looks something like this. You start with a building evaluation that considers everything that the building needs already, where its starting point is in terms of energy specs and that sort of thing, and do an energy model. And then you need a kind of to sort of work those together in an iterative process to dial in the best 2050 ready net zero solution set, and then map out a path to get all the way there, either in one shot or planned stages. So that's the sort of crux of the roadmap. It involves a integrated project delivery on bigger projects that will involve professional teams, but on single family houses, it's a more informal, simpler process, but it's really got to be done to get that plan to lowest cost net zero. And it's when you really map out all the steps, it's complex and highly daunting. And when you consider the vast array of different housing types and building types, and the different levels of conditions of those buildings, different emissions profiles of the local grid, and all of those kind of things, it gets to be it's really, it's hard to know where to start. And we thought initially that we would be able to develop a roadmap where homeowners could look and kind of figure out what to do, but now we've decided that we need a far simpler approach for them that will work for professional teams on bigger projects, but for homeowners, we need a lot simpler solution. And there are some works on, that we're working with Southern Alberta Institute of Technology, SAIT, on a retrofit guidebook to try and simplify some of this. And and develop some of these decision protocols and ways of weighing the pros and cons among the many options. And one tool that we think will be very helpful for this, and we've got to start on this, is a case study library. So there are the idea is something like this. I have a 1950s bungalow in Edmonton, and I look on the in the case study library, and I see a similar project in Saskatoon, and I see the before and after specs and photos, and look at how great it looks at the end. Costs, lessons learned, mistakes made that should be avoided, before and after total cost of ownership, and links to a detailed library showing the things that were done on that particular house. And we've got to start on this on the Retrofit Canada website, and we're looking for funding to grow it and to build it out to where it's got a large number of housing archetypes and examples and different ways of arriving at solutions. And we think this will be a lot more useful to homeowners and even contractors. And a companion piece to this will be a detail library that of practical, proven details and techniques that can be linked to case studies, and we think this will be quite useful, kind of not just for buildings that are similar to case studies, but dealing with penetrations for HRVs and line sets and dealing with the frost issues around heat pumps and all that kind of thing. The solutions for that are arrived at for one building will be transferable to many other buildings. The same, like the library will be large, but it's by no means infinite. And we're working on getting funding to make this a kind of a living document where we can afford to rank the best solutions and review them and keep them updated so that it's useful to anybody doing this work, and ideally gets as people develop better ideas, they replace the ones coming before, so that we can start to scale up this multi-billion-dollar industry that we need to get to address the crisis. So one other way that we think will simplify this, the municipalities are in Alberta, and in lots of municipalities and utilities actually are the kind of gatekeepers for Government of Canada retrofit subsidy money. And we think that and there are some, there's a beginning of this kind of program in Kingston, and I think in Toronto as well, and they're looking at them in BC, where you would have a retrofit coach. So you get your EnerGuide rating done, you bring in the plans for your house or description of your house, and the retrofit coach helps you or dials in the best plan for net zero for that house, and connects you with the available subsidies, and also can review quotes with you so that you're sure that you're getting good value for money on this thing. And I think this is these people are going to be hard to find. They really need a kind of a broad experience in reading energy models, understanding a building condition, and a familiarity with the local construction market. But the precedent they got going in Kingston is encouraging. The only piece that's missing there is the dialing in to net zero. So I thank you for this opportunity, and I'm hoping that we can have a bit of a discussion.
Yes, 3 cheers to discussions. Thank you so much for all that incredible knowledge. Thanks so much to everyone who had discussions in the chat. So to ask some questions of our brilliant Peter, if you just want to raise your hand using the reaction at the bottom, or you can put it in the chat. We'd love to hear your voice, so please come and hop on and share your question or comment. And there was a question from Daniel. Well, we'll go straight to Rob. Rob, do you want to unmute yourself and ask your question?
Didn't want to preclude Daniel. I'm in trouble now. Thank you very much for your presentation, sir. Learned a lot, took a lot of notes. My question's on the employment front related to maybe the energy sprong route to retrofitting buildings. Do you have a ballpark of how many hours or how many people for X number of weeks or months would be involved? And obviously it's going to be a range. Each building, each project's a little different, but do you have any ballpark there?
I don't have a number. All I can tell you is that and it was a comment I should have made when I showed the slide on costs. Most of the cost of these buildings is on site, like the panels and windows themselves, and there would be labor in the panels as well, are about 20% of the cost. The rest of it is
Labor of some
getting the
sort.
building ready, finishing it off. There's a fair amount of other materials, but I'm guessing that the labor component would be 40 to 50%. So we need an army of people, and that's been our biggest challenge as well. Like, this is we're in a branch of carpentry that really doesn't exist right now. We need to train these samurai renovators to we want kind of passive house skills and attention to air barriers, and real attention to detail. And there's some carpentry. We've actually make good use of lower skilled laborers as well. But our biggest challenge, and the reason we're going as slowly as we are, is we haven't been able to get the people we need. And we can train them. It's not rocket science. But we really need people who want to do it and are willing to be conscientious about it. And I mean, it's a perfect opportunity for a young person growing up who really wants to make a difference on climate change. By God, here's your way. You don't get more real than this.
Awesome. Thank you, sir.
Yeah, thank you. And just to add, here in Manitoba, Manitoba Building Trades offers some of this training on passive house. So their theory was to go to the highest possible. So wherever the codes landed, people were ready for the best. And then thus everything in between. So in Manitoba, we do have some of that training coming around. And one of the things SBM is trying to do is understand a little bit more about what's needed. So this is very helpful. I loved that samurai renovators. Great term.
And so, yeah, I mean, we're working with, one of the reasons that SAIT is doing this guidebook is they're using it as a curriculum. I mean, it's a first step toward developing a curriculum for this. And we need people at every level, basically. The scanning, the transition from the scan to the building detailing and drawings, and project managers and lots of folks doing the actual work.
Absolutely. All right, Cam, it's your turn. Do you want to unmute and ask your question?
Yeah, I was curious from the perspective of lenders, like for credit unions and banks, like how do they view this? Personal anecdote, we're trying to update a 1960s house, and we've had assessments and banks look at it, and basically half our budget is energy retrofit and half of it is the standard, new kitchen, new bathrooms, flooring. So the banks value new countertops and kitchen cabinets and new bathroom tile, but they don't, the energy stuff is basically for fun. It's it's really not taken into the valuation of the final home value.
And that's that's something that we've been struggling with for quite a while. There's some institutions that are paying lip service to this, but really they rely on independent appraisers, and there are also getting to be some appraisers who get it. I know Van City in Vancouver completely gets it, and our the Sundance project is being financed by the Service Credit Union, and it's they get it. So I think shopping around will help somewhat, but and then when you're doing that, I would ask the lender for a recommendation for an appraiser who's going to take that into account. But it's I think this is going to change. It has to, but because I think we're going to start to see like the awareness of doing this is, I think, like I've been at this for a long time, and I feel a little bit like Charlie Brown and Lucy and the football, and I keep starting back in the 80s, and it keeps getting yanked away. We got really excited in the early 2000s. Everybody was worried about. So, but I really think that the awareness and the valuation of this in the market is growing pretty steadily, and the progress in the last little while is the most significant so far. And it's so clear that this is an emergency, and I think people are waking up to it. So I don't know if that helps at all, but yeah.
Okay, does that feel good for you, Cameron? Perfect.
I just wanted to share the perspective and wonder if it seems like it's a common thing. So I mean,
it's a very common thing. Don't feel hard done by. Yeah, but do push back a little bit.
And I do know here in Manitoba, Assiniboine Credit Union, who is a sponsor of SBM, one of their guys used to be our board chair. So they've got some good expertise over there. And so Kurt also in the chat was suggesting checking out ACU. So as I'm sure other groups get it too here as well. All right, Shauna, do you want to unmute yourself and ask your question?
Absolutely. Thanks, Andrew, for your Peter, sorry, for your presentation. There's so much good stuff here. I think Daniel's got it. Retrofit map, long-term retrofit coach. I own a 100-year-old house, so boy, I know. I just took the asbestos remediation and all that. And some of the ideas that I developed a case-based reasoning system in the 90s for my doctoral study. So yeah, I know this is kind of kicking the ball down, kicking the ball. Where's the ball now? Yeah. So I think all these ideas have been in place, and it's great to see you actually doing it. So kudos to you and your teams for doing that. My question actually is on. Mercedes is here, but we've been talking a lot about this. We're working with First Nation communities, developing sustainable tiny houses that are off grid, and but part of that is also about material sovereignty. And so I'm wondering about the panels themselves and how much you've considered. Like I saw the vinyl siding. Oh boy, how much?
No, that's hardy siding.
Okay, good.
Actually, the single-family houses we're using. We're using LP siding on, and one of them which I think is really cool, we have taken off the old beautiful cedar siding and are reusing most of it. Like we've developed an architectural scheme that we may even, we're going to try Soshugi ban on it, where we kind of burn the outside. I mean, that's a sort of an artisanal kind of thing, but no, for sure, you know, you're doing this once. You need to make sure that the exterior is durable and that it's installed. That's one of the parts of the value proposition, is using a rain screen, making sure that whatever you put on, it lasts almost indefinitely because it can dry properly. And if it's something that happens to be painted, that the paint lasts longer because it's got no moisture driving through it and that kind of thing. So no, and we're, you know, I didn't talk about carbon. But we're really with the cellulose insulation, we've got basically a wood-based cellulose, you know, a carbon sequestering solution set for the most part.
Yeah, that's exactly what I was driving at. Kind of the biomaterials movement is really coming up now, and
Totally.
Really curious to see how that folds into the net zero proposition.
Well, you know, when you compare it with the carbon footprint of replacing the building, the decision as to whether you use hardy or a pure wood-based, wood and glue based siding it looks a lot smaller, but we're, you know, one of the encouraging things about this whole endeavor is how fast the building and architectural community is waking up to embodied carbon.
Thank you. Any follow-up questions there, Shauna?
People on the call know I'm a professor. I've got a ton of questions, but I'll let other people ask. Alan's got a question.
All right, Alan, if you want to unmute yourself and, oops.
Hi,
Hi.
Excellent presentation. I'm very interested, but I live in a townhouse condo project. I've looked into and actually enrolled in the Canada Greener Homes grant, and it seems to be the piecemeal approach. And from talking to a few people, you know, it would take a lot of money to be able to put together a feasibility study to figure out what to do for our property. Then I'd have to sell our board on it. Then I'd have to convince all the unit owners to go ahead. Is there, you know, based on the Sundance property, how do I get to the decision point of, yes, we're going to do this?
So that, you know, that's a tough one. I mean, at Sundance, it's a housing co-op. It's an original CMHC housing co-op and a pretty forward-looking community. They, but even there, it took some pretty extensive work with member engagement to get the buy-in to go ahead. And in a condo situation, it's harder to, like, you know, that's one of the things behind the sort of case study library, is we're hoping that you'll be able to tell at a glance what you're up against and what kind of costs there are, and also what kind of benefits. But we're a ways away from that. We're consulting on a multifamily in Calgary, where they've got a big, they're facing a huge capital expenditure to keep the envelopes functional. They've got all kinds of problems that a deep energy retrofit would fix. And so we'll see how that goes. But, you know, the more we can do of these things, and a lot of the federal, you know, the energy at the federal government is interested in going to multifamily situations first, because they're, in some senses, they're easier because of the repetition involved. like you can aggregate the work in a way that makes it somewhat more affordable. And so I think that there will be federal subsidies for that kind of work. Whether it's going to be enough to make it worthwhile in your particular case, it would depend a lot on what the buildings need just to keep them going, and what they need in their capital planning and that kind of thing, and how forward-looking your condo board is.
Thank you.
right. Thank you. All right, so we just have a few little questions in the chat. One is coming to us from Connor, who wants to know what computer programs are used to scan and map buildings for panelization.
So the program that would, or the equipment and software that was used are from Leica. It was, the scanner itself is a Leica BLK 360, which is actually not a survey grade instrument, but it's affordable. It's about $25,000 or maybe more with inflation now, as opposed to 70 or 80 or more for the ones that are finer. But it was well registered, and I think they were using, what's it called? Maybe Recap. I can't remember exactly, but they and then as I mentioned, we imported into so the surveyor used some other standalone software to register the multiple scans, and he also surveyed them with the total station. So he had targets on the buildings, and he surveyed those very carefully with the total station and fed that into the registration process, so that we could be sure that the cloud itself was pretty accurate dimensionally. Probably it's good to 2 or 3 millimeters, and then by the time we get it in there, we're good to 4 or 5 in our drawings. I don't know if that helps.
Well, we'll see if Connor follows up with anything in the chat. He says, wow, thank you so much. So you did great. One last question. If we can just quickly answer Zach's question about not using the term passive house. Why not?
Not using which?
He said he noticed that you were not using the term passive house. So could you just say why or why not you would use that term?
I'm a certified passive house consultant, both in the U.S. and internationally, and am it's a wonderful analysis method, and a huge kind of body of building science knowledge that is impeccable, and we use that all the time. But we're using, for the single family houses and most even multifamily, we're using HOT 2000 because it's Canada's, it's available, and it's tied in with the many of the incentive programs, and it's close enough. Like, I've sat down with a beer on a Saturday afternoon and compared the outputs of PHPP and HOT 2000, and as you would hope, any competent engineer writing these formulas is going to come up with kind of pretty similar answers, and the variability has more to do with your kind of starting assumptions. And so, in terms of getting where we need to be, I think that HOT 2000 is just fine. We love to hate it. It's got lots of little quirks that I'm sure that could be programmed out of it. And actually, there's a group called Volta Research that's putting it online with a way better interface. But it's been tested and against actual buildings on numerous occasions, and the results are pretty good if your input assumptions are right.